transmission system is the one of the important one in the helicopter systems, because we are transmitting the motion that is the rotational motion from the engine to the main rotor and the tail rotor. Okay. Because the here aeroplane we are not having like a turbojet engine at all, turbojet aircrafts and all. We are not having the rotor transmission, main rotor and tail rotor is not that, but propeller, turboprop engine, the propeller is fitted, but the propeller transmission which is happening from the engine itself. Engine shaft is extended through the AGB accessory gearbox, and there the RPM is reduced, and the propeller is rotating. That is in the turboprop engine that you have already studied. But here the main rotor transmission is the in the helicopter, the engine RPM, that is engine from the engine power power has to be transmitted to the main rotor and the tail rotor. Okay. So early helicopters, because you need to study about the transmission is taking place in the engine to the main rotor and the tail rotor. So reciprocating earlier helicopters are fitted the reciprocating engine. That is the piston engine. Maybe that some helicopters have the fashion of cylinder arrangement, piston engine, or like a horizontally approached engines. The number of cylinders are just 6, or number of cylinders are maybe 4, or very small helicopters. Depending upon the cylinder arrangement or firing order, the piston engines are classified. Because the reciprocating engine the runs at a speed of low speed, approximately here, so 3000 to 3200 RPM. But the same RPM we cannot rotate the main rotor, because there is a problem when you rotate the main rotor, because it's a complex mechanism having the rotor hub. So it is audible to everyone. Hello.
Yes, sir.
Okay. So the rotor, we have to rotate the rotor like a same speed of the engine. It's very difficult because the rotor, when you have the blades attached with the rotor hub, and the rotor is rotating, you are also balancing statically, balancing the blades with the rotor system as a unit. But the blades are rotating, the speed means the whatever the forces developed by the blades, the centrifugal force, and also it is subject to the flapping and feathering. Okay, so advancing of the blades, retreating of the blades, what we have discussed in the second unit. So these all the blades are producing the enormous amount of the forces because of the compared to the root side of the blades, there is on the tip side which may produce the more towards the tip side of the blades aerofoil section. So the tip of the blades is facing a lot of problem because of this higher rotational RPM. So we cannot rotate. Even the engineers or innovators are design the helicopter blades because it's like a wing. Wing, you are designing the aerofoil section and you are doing the analysis. So the helicopter blades also is a wing, considered as a wing, because the blades of the aerofoil section, when you design with the supersonic aerofoil section, then also they faced a lot of problem with the helicopter running with the same engine speed. Okay, so they reduced the engine, like a reciprocating engine, turbine engine, they have the maximum RPM 6,600. This is the in the Jefferson it's given, but some of the helicopters is more than 6,600 in case of the turboshaft engine. So the piston engine also 3000 to 3200 RPM, that is reduced into the drastically reduced into the 340 RPM. It's the main rotor speed. Okay, main rotor speed here your main rotor speed and is 340. Okay, so 340 it's for that particular reciprocating. It's not a it's a jacker. Okay. So the turboshaft engine also because you preferably why the turboshaft engine for the helicopter. So the turboshaft engine is rotating with the higher speed. One of the engine with the France engine, like a through helicopter, like a Cheetah Chatak, which is R2 engine, R2-3B, developed by this France. Okay, I don't know this, maybe Sigma company. So they are all running with the maximum RPM of 33,000 RPM. So that is reduced due to the like 400 or 500 RPM to rotate the main rotor. Okay, so why the speed reduction? Why we want to have the speed reduction? Because the engine producing the greater amount of power at higher RPM. The same power when you transmit to this main rotor, which is rotating the same speed of like a engine which is rotating at the 33,000 RPM, one of the R2 engine, where I was known about the details of the engine in my service. So that the thousands of RPM can be reduced by the transmission system because if the excessive power, whatever produced at the higher RPM, so that can be utilized for the main rotor and the tail rotor, but it is not a same RPM can be transmitted to this rotate the main rotor. So because when you cannot operate higher RPM, the tip speed, yes, may stay at such. You want to make that tip speed of the blades below that stay at subsonic. Otherwise, there will be a stalling of the blades. Okay. If you study about the compressor blade stall, the same thing here also the blade is stalling. So simply they won't be producing any lift by the aerofoil section. And simply what is the use of now having this much big helicopter nowadays, like military and all, army, force, which are all having the big helicopter like B-17 and all, having the payload, excess payload. Payload means the load which can carry by this helicopter, even two lorry to draw this what do you say, the Indian Oil Corporation, the Bowser, na? Two Bowser lorry you can keep inside the helicopter. So because when you want to take this type of Bowsers for the other stations, other like stations, aeroplane, air force stations. So suppose for refueling or some problem in the wartime, you want to have that quickly because service exigency, emergency is there. We want to transport maximum load, payload. So these type of big helicopters are used for carrying the maximum loads. So these type of because the blades rotate at a higher speed, it's a totally typical problem. You cannot have the smooth stabilizing of the helicopter during flying of the okay. So they want to make the helicopter blades very less subsonic speed. Okay, so they don't want to have the like installing of the blades. Okay, so even the compressor instability is there. Suppose if you study the um, turbo jet and all jet engines by high bypass engines and all. So there is a compressor stability because stall, which makes the blades stall if you have a more stalling angle. The blades and the stability of the airflow inside the whatever the compressor it's having the 18 stage axial flow compressor compressing the stator and rotor and all, which is having the instability of airflow inside the engine, then there will be a flame out. Okay, flame out because of the blade compressor stall. Flame out means the firing because only the no air is passing through the engine. Only the flames are there. It is simply burning the engine blades or burning the entire engine is fired. Okay, so there is a big theory about this stalling. Okay, so here what the helicopter, the main reason you don't want to transmit the more power and we don't want to rotate the main rotor at a higher RPM. We don't want to have the higher RPM because of the more centrifugal forces and because of the tip speed goes above the subsonics. That leads to the brake stall and all. Okay, so these are the reasons why we want to. Even the tail rotor, see the tail rotor is fitted in the rear, okay, tail boom. Have you seen the helicopter? At least helicopter, you have anyone has flown in the helicopter? Hello?
Yes, sir.
Yeah. So that is a lot of vibrations. So whatever the tail rotor, because it's where tail rotor fitted in the tail boom. So tail rotor also the engine from the power engine power. So some of the power has been transmitted to the rotation of the tail rotor through the shafting and through the gearbox. Intermediate gearbox is there, tail gearbox is there. So that the tail rotor also not rotating with the this type of higher RPM of the engine. So maybe possibly the RPM of the tail rotor it is around 2500 RPM. Okay, so we are not going to exceed even the tail rotor RPM more because engine RPM is higher. So there are the gearboxes that can be reduced the engine speed to the lower RPM level, and that can be transmitted to the rotation of the even tail rotor. Okay, so this what the transmission system importance. So while in the earlier days reciprocating engine now has come as a turbo shaft engine. So turbo shaft has got the power turbine and the free turbine. So it is easy for rotation of the this main rotor. Free turbine is directly connected to the main rotor, and there is no starting problem and all. More torque is not required for the starting of the this turbo shaft engine because we want to rotate only the power turbine, not the free turbine. Because the free turbine is totally having some clearance with the power turbine. So the torque required for the starting also less in case of the turbo shaft engine. The free turbine is able to rotate the main rotor to the transmission system. So these are the relationship of engine. This completed this diagram. So relationship of engines and the transmission used in helicopter. If you see that the engine is fitted with the nose section, the first helicopter, the engine is fitted in the nose, and there is a shaft which is connected from the engine to the transmission system. That is, transmission system is fitted below the main rotor. Okay. So there is now the weight of the engine, the nose section, and the shaft which is connecting. Okay, that also increases the weight, and also the visibility. Whatever the load, total balance of the helicopter. So which is on the front side of the helicopter, it's in the nose section because the engine is a heavy part which is accommodated in the nose section. This is not a convenient for the balancing of the helicopter to increase the speed or of the helicopter. Okay, so then they shifted the engine at the base of the um, fuselage, bottom of the fuselage in the horizontal fashion. It is fitted, and from there also you have required the shafts. The very second diagram, if you see, Okay, are you able to understand from this diagram? Okay, hello.
Yes, sir.
Yes. So shall I continue?
Yes.
Yes. Now this is a engine which is fitted in the fuselage, bottom of the fuselage in the horizontal fashion. And from there the shaft is there which is connecting the engine to the transmission system. And the transmission system, from the transmission system, the main rotor is getting the power and okay. So then there is a modification of the fitment of the engine. They thought of having the vertical engine. So vertical engine and along with the transmission system. Like our Eurocopter, we have the engine position okay in the top two vertical engines, and the transmission system is vertical. Okay, but here transmission system is vertical. In the Eurocopter, what we are having in our university, that is in the position in the hangar. Two engines are there, and the two engines also transmit the power to the transmission system, and from the transmission system, the power is okay transmitted to the through the various gear mechanism to the main rotor and tail rotor. So here third diagram, the vertical engine, and above that the transmission also the vertical. So this is one of the modification. Okay. Then the model modification they have done. Okay. The rear, they fitted the engine at the rear, and from the rear, the shafting has been done to go rotate the uh, transmission system, and from the transmission system, the power is transmitted to the various assembly of gears to the rotate the main rotor. Okay, that is the one arrangement. The other arrangement, if you see, the helicopter engine also fitted there in the top, like our Eurocopter. Helicopter is fitted, engine is fitted at the top, okay, with the engine mountings, and the transmission is the vertical. And from the transmission system, the main rotor is fitted. Okay, so this is the one arrangement. So these arrangements, okay, give the so the location of the engines and the transmission system. ஹலோ ஹலோ சஞ்சய், நான் இப்போ கிளாஸில் இருக்கேன், அப்புறம் ஒரு ஹாஃப் அன் அவர் கழிச்சு பேசுகிறேன். ஓகே. So this will be a typical relationship of engine transmissions using the helicopter. So this is the one of the important how the development has gone from the reciprocating engine to the turboshaft engine, and the location of the transmission in relationship with the engine, because they feel convenient of the helicopter. They are all modified and innovated installation procedure from the various from the nose section, middle of the fuselage, and the rear of the fuselage, and the top of the fuselage, okay, which are all convenient to transmit the engine power to the transmission system and to the various types and to the rotate the main rotors, okay, and to the tail rotor. Okay, so this diagram interprets that what I have explained there. Okay, installation of the engine and installation of the transmission system. Now this is the typical that Hillary told helicopter transmission installation. Okay, this is one of the typical only, but it's not a it's a old helicopter having the transmission system. The engine is there in the engine mounting. They are shown. If you see this is the engine mounting. The adapter plate is there. So above that, the transmission system is fitted here. Okay, it has got the lower shield, the main drive clutch housing, connecting shaft, then upper shield, then it is got your main transmission, having the auxiliary generators and various pumps, the tachometers. Then it is the must is inside this transmission okay system. And from the must main drive shop, there should main rotor drive shop. That is the shop. What we are technical name is the must. So from there it is the main rotor coupler is fitted and main rotor blades. So the typical transmission system, which has got the here mainly the clutch assembly, and also the inside the transmission system there is a gear assemblies and all that. They are not shown in this picture. And the same whatever the transmission system, not only helping the transmitting the power to rotate the helicopter main rotor, and also which helps to rotate the various accessories, because here the diagram is shown, maybe the AC generator is fitted, tripod is there, they have shown AC generator, and the RPM tachometer, generator type RPM indicator, rotor tachometer, that is which can indicate the rotor RPM, that is taken drive. And also the other accessories components are also fitted in the transmission system. So that can give the drive to the operate the various components, and that can be maybe the hydraulic pumps, fuel pumps, lubrication pumps. And this also can be rotated, rotate, getting the drive from the transmission system. Okay. So this is the one typical old helicopter killer 12 transmission installation. Actually, this transmission system is installed on the this engine above that rotor plate is there. Engine mounting they are shown. This will be the engine mounting, which have the couplings and all. Okay, and also the strongest this adapting this installation coupling is there. Okay. So in that the transmission system is connected, installed. So this is one of the new helicopter, the modular manufacturing of the components, very compact, very compact transmission system, and which got the number one input model, number two input model, number one accessory model, number two accessory model. What I was discussing this accessory model. Accessory model already I did class last class. I explained about the modular module. What is modular unit? A unit which can be manufactured by the manufacturer, and which is not only solving the one function, it can solve the functions of other units also. Okay, so the combination of all the components and accessories that can be assembled in a single unit, that unit called the module. So last class I was discussing about this modular unit. Okay, so even the like helicopter engines are modular engines. Uh, like fire, even that I saw that one of the fighter aircraft Mirage, which is when I was working that there it's a modular engine because modular engine. Um, that means like a compressor model, accessory gearbox model. Uh, then this core that maybe the compressor and the turbine attachment, the core model. Mm, because when you need not to suppose any repair is there, any maintenance is there, or for the major maintenance. Suppose some of the this one is damaged, blades are damaged in the compressor or turbine. So you can replace particular model, like computer, you are replacing the motherboard or the hard disk, just model, just you are removing it and you are fitting the new one. Okay, so like that, here also the module. Nowadays, all the modular manufacturing. Okay, so here what I have shown here. Are you getting my point? What is the modular unit? Modular unit. Hello. 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 So are you getting my point? Modular unit. Yes.
Yes, sir. Yes, sir.
Yes, yes. Because sometimes I'm only,
Yes, sir. Yes, sir.
yeah, I'm only seeing the slide when I talk to some students. Already the net is gone, and then I am simply last class that it was happened. So I want to check it whether it's going well or not. Okay.
Yes, sir. It is
So
very fine, sir.
yeah, yeah. So that is the module. Main module is the transmission. Input module is the engine. From the engine side, the engine drive shaft is coming. Maybe the two engines. One engine first input module. That module from the first engine, the shaft is there, and the shaft is connected to your transmission system, and that the shaft is okay, rotating the transmission units and all. So like that second, because it's a synchronized. Now we see that even you can stop one engine and one engine can operate. Otherwise, two engines also, if it's running, no problem. Because of the two engines, the gears are different. So the rotational synchronization will be there, and which has got the second model, like a number two engines running means the number two accessory module also is in the operating condition. So this accessory model, they are shown it as a electric generator and a hydraulic pump. So this side also one hydraulic pump, one electric generator. So these are all getting the drive from the same transmission system. So the transmission inside the transmission system, whatever the drive shaft, which is whatever the drive shaft coming from the engine, that they also call it as a coil shaft. QUILLSHAFT coil shaft, because they're very small shaft, which is having the spur gears at the end. That spur gears can be meshed with this inside one of the gears in the transmission system. Even if you see the engine, because I saw that the various engines, how to engine is getting started, how the HPR RPM getting transmitted to the how the starter motor from the starting stage, how the RPM, the starter is starting, how it is rotating the high pressure rotor shaft. But I have also seen in the engine, working on the engines, because if you are able to go in the MRO or overhauling agency, then these are the things you can visualize. Because when the starter motor is rotating, and this starting torque initially that has to be transmitted to the high pressure rotor through the gears only. So that if the gears are meshing with the high pressure rotor, that splines, then the HPR is rotating, the engine is rotating. Same thing here also, helicopter engine is started with the starting motor, maybe the electrical starter or your pneumatic starter. Okay, there are various types of starter we have studied in the systems and instruments subject. You have studied in the fourth semester, systems and instruments. Hello.
Yes, sir. Fourth semester.
Yeah, fourth semester. You have studied the systems and instrument in that starting system, because there are various starters are there. So here also helicopter that can be started with that. So from the starter here, getting the drive, engine is started, engine is transmitting the drive to the transmission system. So this is the one of the transmission system. From the outside, you are seeing that the inner section of the transmission system. That is also I got it from the, so some of the diagram. So here, okay, here this diagram, what is mainly from the main transmission system, the must is there. From the must, the main rotor is connected, and the main rotor is rotating. Okay, so the main rotor is getting a rotation is transmitted from the main transmission. So engine speed I shaft, engine speed I shaft. Okay, so the from the two engines are there, so which is transmitting them. Okay, motion from the engine to the transmission. So there is a shaft, the shaft which is uh, going to the rotate the tail rotor. You see the tail rotor here in the top. So there is a shafting. This is properly installed, accommodated in the your helicopter section, fuselage section, tail section, and which is in between the intermediate gearbox is there. Okay, in between the intermediate gearbox. This is the intermediate gearbox where the RPM is reduced. Okay, even though here we are RPM is reduced, from that, suppose for example, from the main rotor it is going to the some 5000 RPM. From this intermediate gearbox is reducing into the some 3000 RPM. From that it is going to the tail gearbox. Where also the because of the gear reduction ratio, RPM is reduced to rotate the tail rotor. Okay. So these all when you want to have the lubrication purpose here, actually lubrication system are not shown. One oil cooler they shown. Why the main in oil cooler? Because there is a supply of intermediate. Because now this is the okay. If it is a gears or that should be lubricated. Some tail rotor gearbox. So there will be a supply line from the your oil system to lubricate the intermediate gearbox and to the tail gearbox. So then the oil must be recirculated. So you prepare the oil cooler, like heat exchanger. Okay. So that oil cooler is reducing the temperature of the oil, and that is again collected in the system and recirculated. This may be the oil system, which is a wet system. Okay. So someone like a tail gearbox which is lubricated with the gear is grease, then no problem, you do not have this oil cooling system. Okay. Because it's a grease lubricated, solid lubrication. So the gears are running with the grease. Okay. So we need not have the pipelines to go into the this gearbox, tail gearbox or the intermediate gearbox. We need not have this oil lubrication. Okay. So this is the one of the important one. Where the inner structure, where are the some gears, planetary gears are there in the inside the transmission system. See, like a main model engine is rotating the 20,000 RPM. Okay, so engine is rotating 20,000 RPM. Engine input speed here 20,900 RPM. Like that is. So engine input speed is 20,900 RPM. So from the input model, this is coming here. So the tool shaft is driving one of the gears. So 20,900 RPM. Again, there are the gears, okay, arrangement, which can reduce the RPM to rotate the generator. This whatever you have seen that AC generator that is rotating at 11,809 RPM. Okay, again, because of the gear reduction. Okay, because when the gear ratio, because 1:3 or whatever the module, when you fix it on the gears, number of gears, that the pinion and the what you say, the drive gear and driven gear. Okay, pinion and the pinion is the driven gear, drive gear is the big one. So the gear ratio is important. Okay. So that gear ratio, which is reducing the engine input speed. Okay. So to the rotate the generator 11,809 RPM, and also this hydraulic pump model, which is rotated at 7,188 RPM. Okay. So there is a freewheeling, so some RPM 5,700 500 RPM. Okay, here. So then it goes to the Okay, here you see tail drive shaft. Tail drive shaft, if you see 4,116 RPM. From here, from this gear, okay, this planetary gear, the arrangement, it's a perpendicular transmission and goes to the tail rotor 4,116 RPM. And intermediate gearbox you see, there also bevel gears are there. Because gear terminology and the gears are more important because the helicopters, that's why the first unit we discussed about the gears. Okay, so because like spur gears, bevel gears, and helical gears, and how the transmission, how the gear ratio. Okay, that is also important because when you have these okay gears, you can model the gears and you can see the gear ratio and you can also see the how the reduction is taking place because it's maybe one student in the one of my student in the project final year project. So he also actually that was a very difficult job, but he has taken as he's from the like Chhattisgarh, right? So he got a project and he wanted to do that, even though he's average person. And he developed one helicopter slash plate mechanism. He started with the slash plate mechanism because the same what are the above the transmission there is a slash plate mechanism that can be doing this flapping feathering mainly for feathering changing the weather. Started with that, but he made one big helicopter also. And with all the gears and the collective pitch levers, I think which we spent some more like with his son, with not his with his son, with his brother. Okay, so he has made some helicopter, want to donate to this university, one of the engineering college. So and he made a helicopter with this all type of arrangement. He got a one competition event like Aeronautical Society of India. I don't know because I told my other colleague faculty to give some fine tuning in the PPT and that because he submitted to the project everything over, but the competition was in the during finishing the project that time. So he went there, he got selected for out of five. Out of five, he was one of the fellow. Then from that may be from Hindustan University. From there, the call has come. We get into the some three and first he came out of three, he came first, and they got you one function at Lee Meridian Hotel, Star Hotel, and they given some 50,000 cash award and certificates. Now he's working in the Mumbai, Air India. A very average student. He got a lot of arrears and he cleared the arrears. And he is working now in the Indian Airlines, that is Air India in the Mumbai. Yogaraj. So what I want to say, he made the typical component he has taken, made some 56 components in the solid modeling using CATIA, and he has shown the simulation of this mechanism. Very tough, but even though you have shown in the because there is no power maximum, he has done the design calculation, gear ratio, how the model, how the gear ratio transmitted from the from the engine to the transmission and to the slash plate assembly, and from the slash plate assembly, he has made all the design calculations. And same thing, he wanted to go with the fabrication, and also he has done it in the fabrication with some white alloy and steel. Everything. And only thing he could not have the engine because he wanted to build the engine, but cost is going somewhere else. He has shown that when you move the collective and cyclic pitch lever, the transmission is just going to the links to the this one, which will brought to the slash plate mechanism to the blades. So practically he has shown, practically he had a structure. I will show that structure. Okay. So this is the mechanism. You must water that will be gears, gear ratio, and here the pylon drive shaft going to the gears, then going to have the tail gears and tail gears to the your tail rotor. So this is the RPM